What I wanted to do in this research, together with my colleagues, is to identify the original viral genome, the original viral genome type, because the virus mutates, it changes, and you get variants arising, and which is the original one. Because all these mutations have happened without anybody realizing a disease is among us. The first genome that we have is from Christmas Eve in 2019, which is 24th of December, obviously. And what came before that, we don't know. That is the aim of the paper. And what we have reconstructed is the network of possible trees, how it evolved. We've got all the realistic trees included in this network at one glance, which is what other methods can't do. And then we apply what we call an outgroup. That means an independent non-human virus, which tells us inside this cluster of trees, which is the oldest virus genome. Yeah. And as an outgroup, you need something which is non-human. So what do you take? You take the bat coronavirus, because that's very closely related to us. And if you apply that, you find out that a location in the network, which we've called type A, is the original type that would have infected humans.
Okay.
And then it would mutated and change into a type B. This type B was then the first genome to be picked up in Wuhan when the disease became apparent. Researchers might be forgiven for thinking at the time that B is the original type, but actually it's not. It's type A, which in Wuhan is only a minority type, but B has become the majority type during the outbreak. And that is mutated further into C. Now, the C type is not found in the early phase of the outbreak in mainland China. It is found outside. For example, it's well represented in Singapore. I didn't, in fact, start my research in Wuhan. My research started when I realized in early February that the outbreak was a serious matter, not simply like a flu epidemic. And that I needed to start right away with my colleagues to understand how the virus was evolving before it really spreads across the world. So that's the start of the research. What is now important to consider is that the earliest genome which has been placed into the database is not necessarily the origin of the disease. If I had sampled, someone from Scotland and put him in the database first, then obviously it would look as if Scotland was the origin. That is not a valid approach. And I'm saying this because there are people who do take this approach, but that's not the way to do it. The first sample was collected in Wuhan by Chinese researchers on the 24th of December 2019, so Christmas Eve 2019. And that first sample, that genome sequence, is available for study by international researchers. And since then, many hundred, many thousand other sequences have been contributed from across the world. Because we have now in our study in PNAS unraveled the viral tree with the A, B, and C types, we can now do something very neat. We can apply the mutation rate of the virus like a clock to our tree and calculate when the outbreak occurred. And doing this, we find that the first infection, possibly from a bat to a human, happened no earlier than the 13th of September 2019 and no later than the 7th of December 2019. This is what we call the span of time between September and early December, the 95% confidence range. In other words, there is only 5% chance that the infection from bat to human happened before September the 13th or after December the 7th.
Okay.
So the Christmas Eve sample doesn't really tell us about the origin of the disease at all.